Hi guys, it's Agent Hacking, and today I'm going to show you that you don't need a lot of time, effort, or just a bunch of code in general to code your own Python game with the Pygame. So this is a game that I made. It's a really short game. It's only about 100 or so lines in Python, and it's going to be quite laggy on a Raspberry Pi, considering that. Oh gosh, I'm so bad at this. It's going to be pretty laggy on this, considering that it's a Raspberry Pi and I'm using VNC Viewer. But it's a great little script that is quite fun to play with. So, yeah, that's pretty much that. Wow, I actually made that. So let's see what this. So I'm using Genie, which is a pretty lightweight text editor. It's like the only one that doesn't take forever to load on a Raspberry Pi. So this is the code for it, but before I get into that, let's go over some game logic first. So pretty much the entire idea of the game is that you have a ball, right? And if you don't do anything, if you don't press the space button, it goes down. If you press the space button, it goes up. So it looks like it's flapping when you press the space button. Next, you have a barrier. So what I did was I made this very long rectangle, and I made a rectangle go over that was the same color as the background, so it gave the illusion as a whole. So the reason I did this was so I didn't have to keep track of this top part and the bottom part and create them as rectangles. So with this hole, I only have to input one y value so that it changes, and the size of that hole won't change if the location of that if the location changes. So pretty much if the ball hits this part or that part, it'll exit and it'll quit the game. But if the ball goes through here, it'll play a sound and it'll add 1 to the score. So so the barrier is coming towards this ball right here, and if it passes through that, it hits invisible barrier right here. So once it hits near the end of that screen, it'll disappear and it'll reappear towards the beginning. So at any given moment, you'll only have one pipe. So that's the main reason why it's so short. I didn't have to use sprites to keep track of all the pipes in, so that's why it's pretty short. So yeah, that's pretty much it for the game logic. So let's get back into the script. So first I imported Pygame, which is kind of obvious, and then I imported random to have random locations for the hole in the pipe. So I initialized some stuff. I initialized the sound and Pygame itself. I set some display parameters, 1275 pixels with left X and Y. So it takes up the entire screen. Then I defined some colors. I literally just searched up RGB colors, and I just picked some that I liked. Next, I defined a counter for the score, and I set that to 0. Then I set up the sound. So this is the sound that it plays when it hits that the hole. And then I set up the game display itself. So I set it to the display width and display height, and I set the caption to Flappy balls. Then I define clock, which is the frame rate, as pygame.time.clock. So for the font, which I used for the end and the little score counter, I just set it to none. So I set it to the default font with 72 size. So this is where I defined all of the functions. So this is end, where I put at the end of the while loop, which it just updates the display and it sets the frame rate to 60. So this is the ball, the X and the Y location for the ball. This is the radius, 35. So the Y location obviously will change when the user hits the space button, or it'll just go down automatically by itself. And the X button, you could hard code that, but I just decided not to, and in case I want to change it later. So next is the draw barrier function. So pretty much what this does is just draws a rectangle with the pipe color, and I set the x1 variable for the x-axis because it needs to go towards the ball. So then I define the hole. So this is the hole. It's blue, which is the same color as the background, as you can see later, is blue. And x1, which is the same location, so it's in the same relative location as the barrier, and then y1, which is the random. So it's in increments of 125 pixels, so you get a wide range of where the hole can be. So next I drew the ground, so this is obviously green and it just shows up on the bottom, and then the sky, which is blue, so that's the same color as the hole. So next I set up some checkers for the sound and for quit. So this is for quit and this is for the sound. So done equals false, so you can see that in the while loop, and the checker is true for some sound logic, some sound logic that I'll get on into. So this is the beginning of the while loop. Pretty much this entire thing just breaks the loop. So if the event type equals Pygame.quit, it'll pretty much just break the loop, because while not done, so it'll change done to true and it'll break the loop. So these are just a bunch of recs from here to here, just a bunch of recs for collision detection. Most of these are just the same amounts as the rectangles that we drew before. And there's one right here called invisible barriers, which is the barrier at the end, near the end of the screen on the left hand side, that tells the computer to make the pipe disappear and reappear at the beginning. And this is so that's that, and the text for the score counter is just a font, the string of the counter divided by 10, because I was very lazy. So pretty much what happens is the counter is later in the script, but it checks if the ball hit the hole, and then it adds 1 to the counter. However, it checks, then adds 1. Then when it goes back to check again, it sees that it's still hitting the counter, so it adds 1 again, and that happens 10 times before it clears that hole. So that's why I have to divide it by 10. You can fix that, but I was just very lazy and I just decided to divide it by 10. And I set that to the font to be white. So next, so this breaks it if the ball collides with the bottom or the top. So pretty much what I did was I just took the y values, minus the hole for the top, and minus the bottom part of the hole for the bottom. If the ball collides with the ground, then it also breaks the text, so that's that. And also, if the ball successfully goes through, so if the ball collides with the hole, then while the checker, it plays the sound, makes the checker false, then it adds 1 to the counter. So this is the part, so if the ball collides with the hole, it adds to the counter 10 times before it clears the hole. And this is where the sound logic kind of comes in. So while checker, so checker we defined as true before, and so while checker, it plays a sound, then it stops, it makes the checker false, so it doesn't play 2 times. However, once it clears that hole and it's not colliding with the hole, it makes the checker true again, so the next time it collides with that hole, it'll play again. So I just defined a simple pressed definition. So the default value for the ball's y change is 5, so it'll go down, and if you press the space button, then it'll change it to -7, which means it goes up. Then y equals y change plus y, which is kind of self-explanatory. Then it just fills the entire display with white, draws the sky, draws the barrier, draws the hole, makes the hole and the barrier, since they have the same x1 value, go towards the ball at 13 pixels. Then if the invisible barrier, which is at the end, collides with either top or bottom barrier, actually you don't need this or, but I don't know why I just made this on the fly. So if the barrier collides with the invisible barrier, then it redraws that barrier towards the beginning with a new definition of y1, so a new location that hole will be. Draws the ground, draws the ball, then it displays the score. So this is text 1, so that's what we defined earlier. Updates the screen and then sets the frame rate. So that's what we did earlier. Then when this ends, you have to display the end screen. So the text equals the final score, so the final counter before it stopped, divided by 10. And we're going to make that black. Then the end screen is just the same thing. If you exit out, the entire thing will X out, and it'll fill the entire thing with white. Then it'll display the text, and then finally it ends, and you end with a quit and a Pygame.quit at the end, just for safe measure. And yeah, that's the entire code. But you might be saying, well, that's 172 lines. Isn't that like not 100? Well, I did space everything out, and I did add the little notes. So if you do get rid of those notes and you do end up compressing things, you'll find that the final amount of lines in this code is just about 100. So yeah, that's pretty much it.